me a second.
When is your final, Simon? Is it soon? Next week?
My final for math?
Yeah.
My final for math is in 2 weeks.
Okay.
I think, yeah. It's on the 26th.
Oh, okay, good.
Okay, here we go. So we're back to inversing stuff, right?
Okay.
But now we're doing it with harder stuff. We're doing it with logs and...
Okay. Give me the function.
Okay, so we need to find the inverse function of f of x equals 3e to the power x plus 2, or exponentiated x plus 2.
Like that?
Mm-hmm.
Okay. What's the first step? Finding an inverse?
Mm-hmm. You put x to y.
You switch the variables. But
Yeah.
what they really mean, the really first step is substituting y for f of x.
Okay, and then you switch it.
You switch the variables and solve for y. So normally I tell everybody there's only 2 steps for finding an inverse. And that's switch the variables and solve for y. But when they give you the function as f of x, well, there's really 3 steps. First step is use y instead of f of x. They're the same thing.
Mm-hmm.
Then switch the variables and solve for y. So the next step is to switch the variables.
Okay, and...
Now solve for y, which is harder than it looks.
Yeah, that's what I was confused about. That's why I remember.
It's an exponential equation. How do you solve exponential equations?
What do you do? You can log it? Yeah, okay.
Use logs. And the reason you use logs is because if I can get the log of both sides, then I can take that y plus 2 and I can bring it down on the algebra line.
Mm-hmm.
Okay?
Mm-hmm.
But before you do that, you really want to get rid of that 3 also. So let's divide both sides by 3. And now it's equal to that. And I use natural logs every time. It's because natural logs are the language of calculus. Once you get into calculus, you will hardly use any log other than natural log.
Mm-hmm.
There's a number of reasons for that, but...
Oh, wait, can I just say something really quickly?
Yeah.
I think thanks because I would just want to say thank you because on my last test I got an 85%, which is way better than I've gotten on previous tests.
Well, good for you, Simon. That's great.
Yeah.
Yeah, no, I always love to hear success stories. If you got a 65, then don't tell me about it. No, I'm just kidding. No, you always can tell me regardless of what it is.
Yeah.
That's natural log of x over 3. Now I'm going to bring this exponent down in front of the log. In other words, that's a property of logs. I can't do that until I have the equation in terms of logs. And it has to be in parentheses. Okay, just if you ever have any doubt whether you should use parentheses or not, use it. And if you don't need it, it's fine. but if you don't use it and you need it, then you're going to make a mistake if you don't use it. Now, what's the natural log of e?
Natural log of e is... Actually, I don't think we ever learned that. Like what e means?
Well, here's what is true. The log base b of b is always 1.
Mm-hmm.
So the log base 17
E
of 17 is 1.
is
Well, natural log means log base e.
1.
That's what natural log means. So if I'm taking the log base e of e,
Then it's 1. Okay, I see.
so it basically gets rid of that term. And now we're close to an answer.
Yeah, y plus 2.
Which is the inverse, is going to be natural log of x over 3 minus 2.
Mm-hmm.
Now, I could change that if I chose to into natural log of x minus natural log of 3 minus 2. You see why you can do that?
Yeah.
Not sure you would necessarily want to do that, other than that is a number, as that is. So if you are putting out your answers in decimal, then you might want to do that step.
Okay.
I would never do that step because I'm never putting the answers out in decimal. That's the answer I'm given right there. And that's not y, that's y inverse, or f of x inverse, f inverse of x. And it's important to distinguish why that isn't y. In other words, if y started out as this, well, that's certainly not the same y when I get done, right? I have found the inverse. Well, that's not the same, so I can't call it y. But I can call it y inverse, or f inverse of x.
Mm-hmm.
And that's the answer.
Okay. Well, I think this one is even harder.
Okay.
Actually, no, it might not be that hard, but I don't really know. It's f of x equals the ln, the what's it called, of x squared.
That's natural log of x squared. Okay.
Yeah, that's...
This is not harder. There are hard inverse problems, but what they are is when f of x is equal to some quadratic.
Yeah.
Then it becomes super difficult, and you have to accept something that's not intuitively obvious at all.
Mm-hmm.
But this is not going to be hard. First of all, since it's already natural log, I can bring that 2 down to there, right?
Yeah.
Okay. So
Yeah.
I haven't done anything yet.
And then you...
Now switch to variables.
Yeah, switch to variables. So it's going to be x over 2 equals... Oh, I guess I'm skipping a step, but...
It's all right.
Yeah, x over 2 equals the natural log of 1.
As long as you can skip steps and it doesn't cause mistakes.
Mm-hmm.
What I find is that most of the time when people skip steps, it increases the likelihood of mistakes. So I spend a lot of energy into making sure people go step by step by step by step.
Yeah.
Now, if you can do all that math in your head and you want to skip a couple steps and you never make a mistake, then I'm not going to say anything about it. All right. Now, this is not an intuitive answer here. I'm trying to solve for y, right?
Mm-hmm.
What I'm going to do is I'm going to I'm not even sure what this is called, but I'm going to let this be the exponent of e, and I'm going to let that be the exponent of e. And
Okay.
that's a legal mathematic maneuver.
So you do e to
E
the x
x
over
over
2.
2 equals e to the natural log of y.
Huh.
And you can do that because had I started with that, well, you could have said that x over 2 equals natural log of y.
Mm-hmm.
In other words, if the base is the same and you have different exponents, then you can equate the exponents. Well,
Mm-hmm.
if you have two things that are equal to one another, in other words, if I have the exponents already equated to one another, as this line suggests, then I can put any base I want under that. I could make it 2, but e makes more sense because when you have e to the natural log of something, it's equal to that something. In other words,
Yeah.
that turns into y. So y turns equals e to the x over 2, and that's again y inverse. So it wasn't really that hard.
No.
Just a question of understanding this perhaps you've never used it before. This
Yeah, I have.
concept of making the left side of the equation the exponent for a base and making the right side of the equation an exponent for the same base. In other words, if I told you x equals y, well, that I could say 2 to the x must equal 2 to the y. Or I could say 17 to the x equals 17 to the y. As long as you tell me that, all of these are true.
Mm-hmm.
And the reason I want to make this the exponent of e is because that turns into y. And the reason it does is another one of those log rules. Let's talk about that for a moment. If I have b to the log base b of x, that's always equal to x. So
Mm-hmm.
if I had 15 to the log base 15 of x plus 1, that's equal to x plus 1.
Yeah.
So whenever this number is the same as that number, the answer is that, always.
Okay.
Okay? And that's why I want to make the base e, is because
Okay, I
now I
see.
have e to the log
The
base
log.
e of
Yeah, log
y. Well,
e1.
that's
Okay.
equal to y.
Yep.
Okay.
Wait, why is that y negative 1 then?
That because it's the inverse.
Oh, okay, yeah.
The problem was to find the inverse. If I don't put a negative 1 there, if I give
Then
that as the answer, well then that indicates that that y is the same as this y up here. And they're not the same. That's a different y. That's the
yeah.
function. Okay?
Okay. That makes sense.
What we're solving for is the inverse. So technically, when they say switch the variables, you should always kind of think that that's a y to the minus 1. Because when I solve for y, I'm really going to be solving for y inverse or f inverse of x. Since they gave you the problem as f of x, then let's give them the answer back in terms of f of x. Only it's f inverse of x. That is what they're asking for, is what is the inverse of that original
Yeah.
function. Here's one, if you want a tough one, let me show you one. Maybe you've had something like this, maybe not. Notice what happens if I try to solve this. Switch the variables.
Yeah.
Now solve that for y. It is not so easy.
No.
That's
But you have to
the problem.
factor that whole thing out and then...
Well, the problem is it's really, really tough to solve that for y. And this is an easy one. I can actually use the quadratic formula to solve this for y. Okay?
Mm-hmm.
But there's a lot of equations that you can't solve for y. And that makes it particularly difficult to come up with the inverse. So not all inverse questions are going to be easy. It depends on the nature of the function that they give you to begin with. Just in case they give you something like this, let me show you how you do it. You treat x like it's a constant. And you put it with your number like that. With me? Nothing's changed. That's the same.
Yeah, I see.
Okay. Now you use the quadratic formula on this. Well, y is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, minus b is 3 plus or minus the square root of 9 minus 4. A is 1. And c, believe it or not, is 2 minus x. That's what c is. Well, that's what I meant when I said you have to treat x as a constant.
Yeah.
It's all over 2. And now, notice, that's a pretty good answer. In other words, that's y inverse.
And it's 9 minus what? 8 negative or 9
that
minus...
would be the answer. Well, maybe I can...
Oh, you wouldn't actually like try and solve that whole thing out?
No. In other words, your answer is 9 minus h minus 4x, which becomes plus 4x.
Yeah. Over 2.
All over 2. And that is the inverse. And that's a perfectly acceptable answer. It's just very difficult to come up with because it's not a concept that you've learned before, where you treat x as like it's a constant and you group it with the other constant. And then you use the quadratic formula to solve for y.
Yeah, okay. That makes sense.
And yeah, and then you get the inverse, and that's the inverse there. All right.
And
no need to get harder than they're giving you, but that's as hard as you're going to get. Right there is where it's very difficult to get y.
And then here is another one, and it's determine if f and g are inverses of each other. And f of x equals 2 natural log, and then parentheses 5 minus 3x.
What's g of x?
And then g of x is 5 minus e exponentiated to the x over 2, and then all of that divided by 3.
All right. Here's what determines whether this is the inverse of that. In other words, there's two ways we could do it. First of all, we could solve for the inverse.
Yeah.
If it's this. But that's not really what you want to do. There is a definition for two functions being inverses of one another. This is the definition. F of g of x has to be equal to x, and g of f of x has to be equal to x. If and only if both of those are true, is f the inverse of g, or vice versa.
Mm-hmm.
So what we have to do to prove this relationship, that this is an inverse of that, is be able to figure out f of g of x. That's going to be the first thing. Now, if I told you what is f of let's make it f of 1, what would you do?
F of 1 equals 2 to the natural log, and then 5 minus, or 5, yeah, 5 minus 3. You'd replace all the x's with 1, right?
Exactly. Okay? What if I said, what is f of x minus 1? What would you do?
Replace all the x's with x minus 1.
Okay. So you've got the pattern. You know what this means.
Yeah.
Now, what is g of x? G of x is this function. So what we're really writing here is f of 5 minus e to the x over 2 all divided by 3. So let's figure out what that is. What is f of that?
F of that is basically you replace all x's with that.
Let's do it. In other words, it's complicated enough that it's easier said than done.
Yeah.
So the first thing to do is just replace everything, and the second step is to go in and simplify.
Yeah.
All right, so what do we got?
What you got? Sorry, you got the 2 natural log, and then 5 parentheses 5 minus 3, and then all of that. Basically, parentheses 5 minus
Notice
ex.
they're making it very easy on us.
Yeah.
To solve. Okay. That's going to be fog of x, which is sometimes written like this. That means f of g of x. It's a composite function. Okay, now notice that that goes away. The 5's go away. And I end up with 2 natural log of e to the x over 2. Correct?
Yeah.
Okay. Now what can I do with that because I'm dealing with logs?
You can put that in front, right?
Uh-huh. So now I got 2 times x over 2 times natural log of e. What's natural log of e again?
Isn't that just 1?
So fog of x equals
X.
That proves that g of x is the inverse of f of x. And I know the definition says that you have to prove it both ways. In other words, you also have to prove that g of f of x is also equal to x. But in all honesty, I have never ever come across a function where fog of x is equal to x and goff of x is not. So once you prove it that 1 is equal to x, you're kind of done. You've proved that f and g are inverses of one another.
Yeah.
You don't, it kind of depends on your teacher and the problem. In other words, if the problem says prove it by proving that fog of x is equal to x and goff of x is equal to x, then you got to do both steps. But if it just says prove that one is the inverse of the other, you probably can get away with just proving fog of x is equal to x.
Mm-hmm.
Be shocked at any teacher that took off points if you just did the first step, which is all we did here. We didn't do goff. Goff would just be the same thing in reverse, right?
Yeah.
Only instead of g of x, it's g of f of x. So you plug into the parentheses our f of x function, and then you plug that in wherever you see x. So you're going to end up with x as the answer regardless. Like I said, in 8 years I've never seen a function where gof of x did not equal. In other words, if fog of x is equal to x, then gof of x is going to be equal to x.
Yeah.
Some weird function out there where that's not true. Certainly when you're talking about functions like 0 and 1 and those kind of functions, you can have kind of strange results. But it's like in calculus, you will learn that there's only one function in the world whose derivative is the same as the function, and that function is e to the x.
Mm-hmm.
The derivative of e to the x is e to the x. But also, the derivative of 0 is 0. So e to the x isn't the only function in the world whose derivative is the same. There's another function called 0. But that's almost incidental. You don't care that the derivative of 0 is 0. The one that's important is the derivative of e to the x is e to the x. And that's why natural log is the language of calculus, is because the derivative of e to the x is e to the x. No other function can make that claim.
Okay. And I think I actually have to go at 4:30.
That's fine. No problem.
Do you think we can like split the session, do you think maybe? Because I was gone for the first 30 minutes.
Yeah, but we can certainly split the session. Well, I just charge you for a half hour. That's all I charge you for. Now, if you've already paid it, then you just have a credit. So you can use the other half hour whenever you like. Let me pull my calendar up here. I'd like to do something else tonight. So if you can use the other half hour, is Saturday or Sunday work?
Yeah, maybe I'll have to check, but I think maybe, yeah.
You want me to put it down? It's easier for me to do it than for you.
Shoot, I don't know if I want to make a schedule, make an appointment with that with my mom.
You had a schedule online, right?
Yeah, I'll do it.
And do it, and you can do half hour. Like I said, I'm only charging you for what you use. And if your mom has paid less or more than that, then it just works as a balance that you get to use later. In other words,
yeah, you're like, yeah, okay, you balance it out. I get it.
It's totally fair. In other words, you're not going to get gypped, and I'm not getting gypped.
Yeah, it's fine.
By splitting up this session into 2 sessions.
Yeah, okay. Well,
I'll go ahead and leave it as it is now, and then if you want to figure out, you can schedule either another half hour or another hour. It doesn't really matter. Either one works.
Mm-hmm. Okay, well, thank you.
All right, Simon. I will talk to you next time.
Take care.
You too. Bye-bye.